All right, so for the number systems and codes topic, we have a different lab structure than we do for most of the other weeks. Today, for this discussion, we're just talking about our C applications lab, which is the lab that goes with this topic. It is somewhat less guided than our other labs. You're given a fairly short rubric here, just with a number of key items for you to consider. And so I wanted to talk about what those key items are. So the task itself is to create a conversion program to convert back and forth between decimal and binary in whichever direction the user chooses. And in general, when you run your program, you'll ask the user to tell you which way they want to convert, either from decimal to binary or binary to decimal. We're restricting that conversion to an 8-bit number, so 0 to 255 decimal, or 8 binary bits. So the user will select their type of conversion. Your program will then go through whatever logic is necessary to perform that conversion for a number that the user inputs, and then they will give an output to the user. And it must be structured to run again if the user chooses to without re-executing. So you'll have to include the ability to restart the program if the user gives you that selection. So a lot of the programming technique and specific implementation is completely up to you. So you will use the structures and techniques we've talked about so far and used in our previous labs to make these things happen. What I do want to see is that your program is broken down into a few specific functions. One function that welcomes the user and asks for the conversion to be performed. One function that asks for the numbers, or for the binary or decimal number from the user. And then one function that performs error checking on these values as much as possible. This is an area where you will kind of stretch your mind on what kind of incorrect inputs could a user give you and how can you check or correct for those. The more correction, the better, to make sure that the user has input a decimal number within the 0 to 255 range that you want, or a binary that is only 8 bits and is made up of only ones and zeros. So you have some flexibility to come up with some interesting algorithms to check those things. They're not an easy task, but most of your thought may come into this error checking portion of the program. And if there is an error with the number, you don't need to perform a conversion, you just need to report to the user your number was incorrect or not valid, do you want to try again, and let them restart the program. So your fourth function, then third was error checking. Fourth will be to perform a decimal to binary conversion if that is what was selected. And the fifth function will be to perform a binary to decimal conversion, so the other way around. We have the grade breakdown, 250 points total. So 50 for the entire program working as requested. Here we have 30 points for each of the 4 functions implemented successfully. So these first two are actually just nested in one function in terms of the grading rubric. The welcome and getting the number from the user are in one block. And then error checking is its own block, and then the conversions are their own functions as well. So 4 separate functions that I will actually be looking for when I grade this code. Then 50 points for fully and helpfully commented code. You have a lot of liberties in how you implement your algorithm here and what types of error checking you want to do. You may implement some mathematics that we haven't talked about in class or whatever you come up with. So you need to fully and helpfully comment this code so that as I'm reading through it, I can see what you were doing or trying to do and so forth. You will just be submitting a PDF again. I can copy and paste this PDF and run it, so it's not that I won't be running these at all. If there's any question on is it working or not, I'm happy to run these on my end. It's not very difficult. But your submission just will be your commented PDF of code. and your code should encompass these 4 functions. So in general, you need to perform some planning for this, and I've got a blank space to do a little bit of the planning here, but essentially we need to start our program. Then our first function here is going to provide all the text to welcome the user. So we'll welcome the user and obtain the conversion and the number that they want. So within this first function, you need to learn, are you going from binary to decimal or decimal to binary? And that information will be returned back to your main program for what type of conversion do they want, and you also need to get an input from the user for what is the number itself. So that's one of your function structures. You have a lot of flexibility in how that happens or how this number is sent back. But that's essentially one part of what's being graded. The second part is once you have that number, you need to pass that number to another function for performing error checking. And you'll also need to know what type of number the user thinks that is for the error checking. So is it binary, which means it has to be 8 ones or zeros. So try to think of some ways to try to constrain and make sure the user has done what you asked them to. The trickiest error checking that you'll have to do is if it's a binary number. This has the most complexity, so do your best here and think of as many error checking mechanisms as you can. If it's a decimal number, is it between 0 and 255? You have a bit easier time determining that, but that'll also happen in your error checking function. And then, based on which conversion type it was, you're going to perform that conversion, either decimal to binary or binary to decimal, binary to decimal, or decimal to binary. We covered how to do that in the topic background about numbers in terms of separating decimal digits using integer mathematics. So using integer math, you can get at those individual bits. You can use a very similar process to get the individual bits of your binary and then multiply them by their weighting factor and add them back together. So double check the background to make sure you're clear on how to perform those conversions. And then you will report that back out to the user. So I'll just put report. So you'll let them know here's the answer that you requested. And then basically again, right, do you want to run again? A-G-A-I-N, that's the word again squished in there. If not, then you can just end the program. If they do want to go again, that is the case where you'll just loop back to your start. So you'll have one big super loop surrounding all this. And we've discussed that in the past. An example of a super loop would be a while one, which means this loop runs forever. However, while one is not what we want here because we do want to get out. So we're going to have to you'll have to make some variable that tracks, did they want to run again, yes or no? And then while they did want to run again, which you'll have to initialize it so it runs at least once, which may make a do while more appropriate, that'll be your sort of larger super loop application that you have going on. So this is just some very basic planning. Try to break this program down into steps. So just make one complete function at a time. Welcome the user, find out what kind of conversion they want, and capture the number through this first function in your main application as needed, although there shouldn't be too much in your int main. So figure that out, get it totally working. The same thing will happen down here. Find your error, get that totally kind of working. Conversion algorithms, get those working. You could do these in some different order because you, the user, can put in things that do not have errors. And then finally, work on your reporting that output, and that one will be pretty simple. So that's the overall brief planning for this project. On your end, you're going to want to break this down in stages and make sure that you give a good amount of thought to each step you're trying to accomplish. And then finally, in the end, or as you write these really, comment this thoroughly. So if you work on it a few hours now and then come back to it tomorrow, you don't forget what you've done. So commenting is a very useful tool to keep yourself on track, as well as keeping others who might see your code up to date as well. So that's the background planning involved. Good luck on the C Applications Lab. Help each other out coming up with ideas on things like error checking. And let me know if you have any large questions or concerns about this. So go ahead and get started.